Welcome to our lesson 2 on longitude and latitude. Okay, so in the previous lesson, lesson 1, we looked at positions. Today we are going to look at great circle. There is a lot of stuff I've written here to save time so that we go through it as you understand. Okay, it is on the board longer. So I have here a circle whose radius is capital R. I want you to relate it to great circle or longitude. Great circles are in two forms. One, longitudes, or all longitudes are great circle. Latitudes, we have only the equator. So the latitudes, the lines running from east to west, there is only one great circle known as the equator. The rest of latitude are also known as small circles. So when I write great circle, its radius must be capital R, so that we distinguish it from small circle whose radius will be referred to small r. So suppose you have someone flying from point A to point B, okay, along a great circle, because it is a longitude. So you are, for example, from southern hemisphere to the northern hemisphere, thereby subtending angle theta at the center. So if we wanted to calculate the distance covered, we would simply use the formula for arc length, part of circumference. Theta over 360 can be read in layman's language, part. 2 pi r is the circumference. So I can say in layman's language, from A to B is part of the circumference. Which part specifically? It will be theta over 360. That is a fraction of circumference. Now, one thing you must note that as I use this formula, the units of arc length will take the units of r, be it small r or capital R. It is the one that gives the unit of arc length. I want us now to shift gears to mathematical table. When you open page 28 in your mathematical table, okay, I think you can focus there. You can see here decimal of degrees to minutes, okay? Minutes to degrees, or degrees to minutes. You can use whichever, but I prefer this version down here, not this, not minutes to degrees. I prefer decimal of degrees to minutes. And you can pay attention at this second row. 0.1 degrees gives you 60 minutes. Here, okay? 0.1 degree gives me 6 minutes. If you multiply both sides by 10, 0.1 by 10, you get 1. 10 by 6, you get 60. And that is what I have quoted here. 1 degree is equal to 60 minutes. And we also know, or you have to know, 1 minute at the center subtends an arc length of 1 nautical mile. Here is the diagram. From this circle, an angle of 1 minute is subtended at the center. So the distance covered along the circumference is 1 nautical mile. So if you have 1 minute at the center, on the circumference it is 1 nautical mile. So our degree is what we need to know. We are not very much conversant with minutes in terms of questions. The questions that we get will handle the angle in degrees. So I've given a quick relationship here. If 1 degree is the same as 60 minutes, okay? This is the relationship between angle and angle in degrees and angle in minutes. So this is about angles. The second one relates angle and distance along the circumference. An angle of 1 minute at the center, an angle of 1 minute at the center of the circle. This will give an arc length of 1 nautical miles. 1 nautical mile. Okay? So from these two relationships, 1 minute, 1 nautical mile. What about 60 minutes? It will be 60 nautical miles. So in place of 60 minutes, I can as well write 60 nautical miles. Okay? So this is the key to us. So generally, if this angle at the center of great circle is theta, remember the heading is great circle is theta, then what will be the nautical mile along the circumference? So from relationship 1 degree at the center, the angle subtended, if it is 1 degree at the center along the circumference, it will be 60 nautical miles. What about if we say generally angle theta at the center will give us how many nautical miles along the circumference? You cross multiply and you will find theta times 60, which is here. Okay? Theta times 60. Maybe I write it the other way, it will be better. It will be theta times 60 nautical miles. In other words, if the angle at the center of great circle is 10 degrees, and I want to know what was the distance covered along the circumference, then it will be 10 times 60 nautical miles. What about if the angle at the center is 100 degrees? The arc length will be 100 times 60 nautical miles. This is true for only great circle. So let us focus down a bit. I talk about small circle. But before I get into that, we have to get the relationship right. Maybe I focus up to there. Yes. Here. If this is our globe or a circle representing the earth, I have OA representing the radius at the equator. And if I talk of a circle, small circle, alpha degrees north, e.g. 40 degrees north, then it means on the northern part there is a latitude whose radius will be small r, not capital R, because the only latitude which is a great circle is the equator. So if I say 47 degrees north, then this is 47. From the horizontal level, you've gone up, you can draw the circle up there, which is latitude. Now, if you study this diagram, CB is parallel to OA. Therefore, if this is alpha, even this one is alpha. Okay? OA, this OA is equal to OB. They are radii, which will be represented by capital R. OA is the same as OB, which is radii, represented by capital R. CB is the radius of the latitude up there. So it is represented by small r. Now, using comparison here, or if you extract triangle OCB, if you extract with this here as alpha, so that is a latitude angle, alpha. How do you know latitude angle? It is a figure expressed with N or S. 20 degrees north, then 20 is latitude angle. 50 degrees south, then 50 is latitude angle. A latitude angle is expressed with either north or south. So using SOHCAHTOA, you can pick K of CAH. Cosine relates to adjacent and hypotenuse. So I can say cos alpha is equal to small r over capital R, giving me small r is equal to capital R cos alpha. Okay? This is very important for us to know. Okay? But what about small circle distance? Small circle distance. So I will just squeeze something here. There is a small circle. I'll draw it like an oval, but it is not oval. Okay? This is the continuous, is what you see. This is what you don't see. And I've drawn from here to there. This is my B, this is my C, this is small r. Okay? That way. So now, let us suppose somebody, this, let me still use theta as the angle subtended at the center. So let me now, on the plane of this latitude, I have letter D. That on the plane, on the surface of latitude, somebody moved from point D to point B. Okay? And the radius of this latitude is small r. So basically, how do I get arc length dB? So arc length dB will be the angle subtended at the center of that circle over 360 times 2 pi small r. Now see the difference. For great circle, I used capital R, but for small circle, I'm using small r, because this is a latitude. Its radius is not the same as that of a great circle. But you have already known here the relationship. Okay? That in place of small r, I can write r cos alpha. Therefore, I can say this is theta over 360 times 2 times pi times r cos alpha, where alpha is latitude angle, an angle that is given with respect to north or south. It is the one you put here. Now, you may not be given small r, you'll be given the radius of the r. It is the one which comes here. So this formula now gives you the distance along a latitude, and it will take the units of capital R. It is R that dictate the units. Okay? So that is what you do. We shall continue now with small circle. I've only given you a preview of what will be in lesson 3. Keep on subscribing. You get more stuff, then you practice. At the end of basics, which is lesson 3, we shall have 1 or 2 lessons relating to problem solving. Till then, subscribe. Bye-bye.